Problem 193, Classical Mechanics. The question is, a particle of unit mass moves in the xy plane in such a way that x dot of t is equal to y of t and y dot of t is equal to minus x of t. We can conclude that it is in a conservative force field which can be derived from the potential. In the present problem, two equations are given. We have to find out the corresponding potential. It is given that the particle of unit mass moves in the xy plane. Therefore, the kinetic energy is half mx dot square plus half m y dot square. It is given that x dot is equal to y and y dot is equal to minus x. That is, x double dot is equal to minus y dot, but y dot is equal to minus x. Hence, we can write x double dot is equal to minus x, or x double dot plus x is equal to 0. This is one equation of motion. It is in x. Similarly, we have y dot is equal to minus x. Therefore, y double dot is equal to minus x dot. But x dot is equal to y. Therefore, y double dot is equal to minus y, or y double dot plus y is equal to 0. This is another equation of motion in y. Now, we have to find out the potential corresponding to the equation of motion representing equation 1 and 2. Let us assume that our potential V is equal to half x square plus y square. That is option A. Now, if a particle of unit mass moves in xy plane, then the kinetic energy T is half x dot square plus half y dot square. Therefore, the Lagrangian L is equal to half x dot square plus half y dot square minus the assumed potential half x square plus y square. Now we have the Euler-Lagrange's equation of motion. Since here two coordinates are there, therefore we have two equations of motion. The first one is dou L by dou x minus d by dt of dou L by dou x dot is equal to 0. The second equation is dou L by dou y minus d by dt of dou L by dou y dot is equal to 0. Here we have taken the potential V is equal to half x square plus y square. Our first equation becomes minus x minus d by dt of x dot is equal to 0. Our second equation becomes minus y minus d by dt of y dot is equal to 0. This implies x double dot plus x is equal to 0 and y double dot plus y is equal to 0. This is the same as equation number 1 and equation number 2. That is, if we assume the potential V is equal to half x square plus y square, then the equation of motion is x double dot plus x is equal to 0 and y dot double dot plus y is equal to 0. That corresponding to x dot is equal to y and y dot is equal to minus x, which is given in the question. That is, we can write x double dot plus x is equal to 0 and y dot double dot plus y is equal to 0 is possible if the potential V is equal to half x square plus y square. Hence, from the given option, option A is the right option.